Okay. The temperature at the temperature G at time t of a given point of a heated iron rod is given by that. Find the interval when the derivative is greater than 0. So if we have the derivative, this is quotient rule. So we're going to have this squared, this times the derivative of u minus u times the derivative of v. All right, so this is t to the 1/2 over t. So t to the 1/2 over t is, you would subtract the exponents, 1/2 minus 1. So this gives 1 over t to the 1/2, or root t. And this is natural log t over 2 root t. And then this is over t. If we multiply by 2 to get the same denominator, we're going to have 2 minus natural log t over 2 root t, and then we flip and multiply. So that gives you 2 minus natural log t over 2 t to the 1 plus 1/2, 3/2. And if we find when this is equal to 0, multiplied by the denominator, so we have 2 minus natural log t is 0, 2 is natural log t, e to the 2 is t, and then we find on either side of e to the 2, and it has to be greater than 0, so this can be 1, so we want to substitute 1 in, and then on the right side, since e is like 2.718, we want to substitute in, we can just substitute in, 3 squared is 9, so we can substitute in 10, just to be safe. So when you do that, you need to substitute into the derivative. So 2 minus natural log 1 is just 2, because natural log 1 is 0. And then we're going to have over 2. So this is a positive number here. And if we do 10, 2 minus natural log 10, this will give a negative number, okay? Because we're thinking e to what will give us 10, and that's over 2, okay? So this is a negative number. So if we want when the derivative is greater than 0, for a, we have t's less than e squared. All right, find the interval when the second derivative is greater than 0, and the interval where the second derivative is less than 0. So we need to do a second derivative. So we're going to have 2t to the 3/2 squared and 2t to the 3/2. And then we need a negative 1 over t for the derivative of u, minus 2 minus natural log t times, we need the derivative of v, which is 3t to the 1/2. All right, so if we just simplify this a bit, we're going to have 4t cubed on the bottom, and then we're going to have negative 2t to the 1/2, which I'll write as square root t. And then we have minus, so 6t to the 1/2 plus 3t to the 1/2 natural log t. All right, let's set that equal to 0 and find when the second derivative. So if we cross multiply by 4t cubed, we're going to have negative 2 root t minus 6 root t plus 3 root t natural log t equals 0. If we factor out root t, this is going to be negative 2 minus 6 plus 3 natural log t equals 0. So either t is 0, which it can't be, or negative 8 plus 3 natural log t is 0. So 3 natural log t is 8. Divide by 3. So e to the 8/3 is t. So now we need to find out, if we draw a number line, e to the 8/3. This is 2 2/3. So we can still do the second derivative at 1, that's before, and we can do e to the 3. I don't know, you just use your calculator. I doubt stuff like this will come up. So now we need to substitute this into this. That's the second derivative. All right, so we're going to have -2, -8 plus 3 natural log 1, so that goes away, over positive. So this is going to be a negative here. And if we substitute in e to the 3, we're going to have -8, -8 e to the 3/2, because we have the square root. And then plus 3e to the 3/2, natural log e to the 3rd. And then this is over, this will be a positive number, whatever it is. Okay? So here, this is going to be -8e to the 3/2. This is 3, so plus 9e to the 3/2 over a positive number. So this is going to be a positive here. So if we have, so the second derivative's greater than 0 when t is greater than e to the 8/3. So second derivative greater than 0 here. Second derivative less than 0 for t less than e to the 8/3. But I forgot about, because t has to be greater than 0. So this one needs to be like that. So those are those two. All right, it says let the value of t where the graph of g has a point, find the value of t where the graph of g has a point of inflection. So that's here, because it changes concavity from negative to positive. So that's t equals e to the 8/3. 3 marks for that, great. T star is the value of t for which the derivative at t star is 0. So that means we've already found that. That's here. E squared has the derivative 0. That's the only time the derivative is 0. Remember, we set it equal to 0 here, and we found that. And the second derivative at this point needs to be less than 0. Well, we know e to the 2 is less than e to the, this is e to the 2 2/3. So we know the second derivative there is negative. So we know t star is e squared. Find the point where the normal, to the graph of g at the point t star. Okay, so we're going to have e squared, and let's find g at e squared. So that's natural log e squared over square root of e squared. So this is 2 over e. And the normal to the graph. So if we've got a horizontal tangent, there's like a max or a min here at e squared because the derivative is 0 there. So we just need x equals e squared, because we would have like a max or min, and this would be the line 2 over e. So the vertical line, the normal to that line, is going to be through e squared. So we want to find the point where the normal to the graph of g at t at that point meets the t-axis. Well, again, it's e squared 0, because this is e squared. So that's where it meets the t-axis.